Hello! In this video we will talk about digital and analog signals, what they are and how we can use them with an Arduino. Let's start with digital signals. A digital signal represents a series of discrete values. In an Arduino, it is limited to two values it can alternate between. One of them being ground or 0 and the other the supply voltage 5 volts. These two states are also called low and high. In practice, the signal won't be perfect and noise and distortions will be present. Contrary to digital signals, analog signals are continuous and represent real numbers. We can use a digital signal to turn an LED or DC motor on and off, but to be able to control the brightness and speed, we need to use an analog signal. All of the pins on an Arduino Uno can be used as digital pins for writing and reading digital values. For writing analog values, you need to use the PWM pins marked with a tilde symbol. For reading analog values, you need to use the analog input pins, whose names start with the character A. We will now demonstrate a blinking and fading LED by using both digital write and analog write functions. To follow along, you will need an Arduino, a breadboard, an LED, a 220 ohm resistor, and some hookup wires. First, connect the used PWM pin to the resistor. Here we are using pin 9. Then connect the longer positive leg of the LED to the resistor and the shorter leg to ground. Next, the code. First, the LED pin is defined and the mode is set to output. At the start of the loop, we use the digital write function to turn the LED on and off. Between the turning on and off, we are using a 1000 millisecond delays. After the digital signals, we use the analog write function inside a for loop to change the brightness of the LED. When measuring analog signals, they need to be converted to digital ones. This is done with an analog to digital converter, ADC for short. An ADC samples the signal and converts it to discrete values. The two most important characteristics of an ADC are its resolution and sampling rate. The resolution of an ADC defines how many discrete values the converted digital signal has. The resolution is expressed as bits. For example, a 10-bit resolution translates to 1024 discrete values. Together with the measurement range, we can calculate the smallest measurable change in the signal. For example, a range from 0 to 5 volts and a resolution of 10 bits means that the smallest measurable change in voltage is around 4.9 millivolts. To capture the frequency and form of the signal being measured, we need to have a sufficiently high sampling rate. According to Nyquist's theorem, the sampling rate has to be more than 2 times higher than the highest frequency of the measured signal. If the sampling rate is too low, aliasing will occur. This phenomenon is when the measured signal does not match the real signal, even if it appears to be correct. Just from looking at the graph, it's not possible to tell if aliasing has occurred. That's everything for this video. Thank you for watching and see you in the next one.